We continue our grade 10 quadratic functions review with this chart, and this is actually a duplicate of what we did in grade 10. So it's more of the same stuff. Like I said, this lesson is going to be broken up into 2 different parts. We're going to start it off today, and then we're going to continue it tomorrow. So you can see at the top of the page, I have the quadratic formula, the quadratic function written in 3 different forms: standard form, factored form, and vertex form. And for each of those forms, we're going to be answering the following questions. So remember, when you graph these different forms, you end up getting the shape of a parabola, right? So you're always envisioning a parabola when you're thinking of these questions. When we ask about the direction of the opening of the parabola, there are 2 options. Our parabola can open up, or our parabola can open down. If it opens up, that means the first term, the x squared, is a positive. And if it opens down, that means the x squared is a negative. So we're going to look through all of these examples, and we're going to just look at the first term. For standard form, we have positive 3x squared. So is that opening up or down? For the next example, we have a negative in the outside. So is that opening up or down? And on vertex, we have a negative 2. That means it's opening. And I think it's we're in luck because we already practiced all of our parabola stuff in the last unit, so this should hopefully go a little bit better. To figure out the y-intercept, you have to use algebra. You have to let x equals to 0, and you have to solve. So that's what we're going to do for all of these examples, beginning with this first one. When you put in a 0 here, you're basically just going to have 3 times 0 squared plus 24 times 0 plus 36. And you're probably like, why did I get so much room to do this question? And it's because you'll see. That's why. So that's it for the first question. Our answer for the y-intercept is going to be 0, 36. And just remember, for x-intercepts and y-intercepts, you always want a coordinate because that's really the proper way to write it. For the next example, again, we're going to put in a 0 wherever I have an x, and we're going to solve. So I just get 0, 24. And then for the last example, this is the one where it's going to require the most amount of work because we have negative 2 bracket 0 minus 2 squared plus 18. That's why I gave you more room just in case you need it here. Although it's not that many steps. I don't know what I was thinking. So negative 8 plus 18, which gives you a 10. And so therefore, our vertex is 0, 10. Okay, this is review, right? Make sense? All right, let's keep going. How do we figure out the y-intercept, or so the x-intercept? Well, this time we're going to let y equals to 0. And for all of them, we're going to factor. So let's try that with the first one. I'm going to let y equals to 0, and I'm going to get 3x squared plus 24x plus 36. Whenever you have a quadratic, the only way you can, well, not the only way, but the only way we know so far to find the x value is to factor. This looks like a complex trinomial, but we're going to factor out the 3. And then we get a simple trinomial. And we're going to solve that. And then from here, we basically take each factor and let it equal to 0, and we solve. So it's kind of like saying x plus 6 is equal to 0. That means x is going to be equal to negative 6. And x is going to be equal to negative 2. And just like before, I like to rewrite this so that it's an actual coordinate. Negative 6, 0 and negative 2, 0 are where you will find your x-intercepts. Does this make sense so far? Okay. For the middle example, it's already in factored form. So do we need to do any work for it? Nope. So I'll just write it again. We have negative x plus 4 and x minus 6. The work is already done. We just need to solve each one of these. So it's going to be x is equal to negative 4 and x is equal to 6. So our coordinate will be negative 4 comma 0 and 6 comma 0. No. And same with the first example, the 3 doesn't affect anything. For the last example, this is where we're going to have to do the most amount of work. In order for us to factor this, we actually first have to expand it, get it into a trinomial, and then from there factor it out. So this is what I got. Check to see if you got it. All right, you guys. For the last portion of the first part of this lesson, we are going to review how to figure out the vertex when they are in the different forms. I have rewritten all of the equations over here, so you don't have to keep flipping back and forth. You can just look over there. When something is in vertex form, what we're going to do is, when something is in standard form, what we're going to do is we're going to convert it to vertex form because that's a really easy way for us to find the vertex. I have a worked out example over here. And if you take a look at it, once it's in vertex form, all you need to do is take a look at this number and change the sign. So I believe that says 5/2, which means it's going to become negative 5/2. And then you just write this number as is. So it's going to be 31/2. But you can only do this when your equation or your function is in vertex form. Luckily, we just learned how to complete the square. So we're going to go ahead and complete the square with this question, get it into vertex form, and then figure out what the vertex would be. So just for practice, go ahead and try this yourselves, and I will do it up here as well. We have f of x is equal to so I factored out the 3 first. And if you're just following along with me, I completed the square with the number 8. So 8 divided by 2 is 4. 4 squared is 16. I added a 16 and I subtracted a 16. Then I recognize that this is a perfect square trinomial, and I factored it to get x plus 4 all squared. And then finally, I distributed the 3. So I got 3 bracket x plus 4 squared. Then 3 times negative 16 is negative 48. I collected like terms, and that's what I get in my vertex form. To get the vertex from that, it's going to be the positive 4, but switch the sign. So it'll be negative 4. And then the negative 12 is just the same. So it'll be negative 4 comma negative 12. We're actually going to go to the last example before we do the middle one. And the reason why is because the last example is already in vertex form. So do I need to do any calculations for this? Nope. The vertex would just be 2, 18. Okay, and then for the last example, you may or may not remember this, but when something is in factored form, the way you find the vertex is a series of steps, which I'm going to show you right now. Yes, I'm glad you pointed that out. It would be 69, 154. Okay, when something is in factored form, what you're going to do is first you are going to figure out what each of the x's are. So in this case, our x is equal to 18 and our x is equal to negative 12. Then the idea behind this is when you have a parabola, that parabola, let's say you have two x-intercepts there, the vertex can be found directly in the middle of the two x-intercepts. So to find the center of the two x-intercepts, we are going to take an average of those 2 points. And the work is already done for you for this example. We take 18 plus negative 12 and divide by 2. That's taking an average of those 2 points. And that tells us the x value of our vertex, which is going to be 3. How do you find the y value of your vertex? Well, what you're going to do is you're going to take this x value of your vertex and put it back into the original equation. So it would be like 3 subtract 18 times 3 plus 12. I haven't given you enough room to work this, but we will do it in more detail in the second example. I can tell you that this is going to be negative 225, which is the negative part of your the y part of your vertex. Let's do it again a little bit more slowly for the actual example that we have in our chart, and then we'll stop there. Okay, so I have something in factored form. I'm first going to determine what both of the x's are. So I have x is equal to negative 4 and x is equal to 6. Now, to find the x of my vertex, I'm going to take an average of these 2 points. So taking an average means you add them up, negative 4 plus 6, and you divide by 2. That's going to give me a 1. For the next part, I'm going to take this 1, and I'm basically going to put it in both of the x's of my equation. Because we have the room, let's show this work. So y is going to be equal to negative 1 plus 4, 1 minus 6, which is going to give me negative 25. So therefore, my vertex is going to be 1, negative 25. Sorry, it is positive. Yep, you're right. Positive 25, and this is also going to be positive 25. Gave you a scare there. Okay, so this is the first part. I'll stop here so we can continue it next class.